I'm Dion McMurtrie. I'm here to talk to you about the sort of introduction to FHIR Terminology Services, and then the next one after this, I'll be talking directly after this, is into more of the advanced topics. I work for CSIRO, which is Australia's science agency, specifically part of the Australian Health Research Centre, and probably known for, in this circle, for sort of OntoServer and those terminology services, but also John, who was just talking before about AI. We do a whole bunch of research. Anyway, yeah, for this session, essentially the learning objectives for this are to introduce you to the basics of the FHIR Terminology Service, what it is, when you might want to use it. We'll talk through the key resources and key operations that go with those, trying to understand the practical use cases for it and what you might use it for. Appreciate some of the benefits of it and what it actually brings, which is, you know, pretty impressive. And there's also some global trends to be aware of that I'll try and cover off, and finally leave you with some resources to go and look through more. So we'll start, I guess, first talking about terminology itself and why it's actually important. Hopefully there's enough people here that are interested to know that it is important. But the simple thing is that good information is critical to the delivery of good, high quality, safe healthcare. And it's particularly important as well for monitoring, analysis, policy development, research. All of these things are, it's the lifeblood of all of those things. But the information, the data in health is quite complex, and standardization of that language and meaning is a constant process. It's a constantly evolving thing. You look at something like SNOMED CT, it's like, as we would say in Australia, painting the harbour bridge. You're never done. It's always going to be going on. But to apply the sort of sophisticated tools we want to apply, we really do need that high quality data for safe information exchange, to enable the sorts of things that we want to do with analysis, reporting, decision support. We need to make sure we've got the same meaning at both ends of exchanges understood really well. And to do that, we need coded, structured and computable data. So in that context, terminology is the kind of the codified meaning, and FHIR is like the structure, and there's a number of different sort of ways of representing that structure, and FHIR's obviously a pretty good one. So what is the FHIR Terminology Service? So we'll just talk through the definition that's actually in the spec. So looking at the FHIR Terminology Service, it's a service that lets healthcare applications, and that's a pretty broad church, so that includes clinical information systems that are facing clinicians through to analytics platforms and everything in between. Make use of codes and value sets. It probably implicitly talking about ConceptMaps and things in there as well. The key bit is without having to become experts. So there's a lot of complexity embedded into a number of these large coding systems and terminologies. But it's about having to become an expert in the fine details of the resources that make up the FHIR Terminology Service. You can get into a lot of detail, and I've got another session after this which does get into some of the more esoteric parts. But the services are supposed to mean you don't have to become an expert in those things to be able to use them and do what you need to do. And probably the last one is having to become an expert in the underlying code systems and terminological principles, which can get quite complex, particularly if we deal with things like SNOMED CT is probably one of the most complex. So in terms of what you might be doing with terminology, look at taking a sort of a use case view. The obvious one's data entry. So you've got a user interface. You're trying to capture coded data from a clinician or a different type of user as well. Validation. So I've got a code. I've got some coded data. I want to find out whether that code is right for that particular element. Just finding out about some coded data. So I have a code or a set of codes, and I want to understand how they relate to each other, or get some of the properties that they might have in common. Mapping's a very common thing, and a whole set of use cases to say, I've got this code in this code system, I want to go to this other code system. How do I do that? And then analytics, which does use a number of those different techniques. So I've collected all of this coded data, and now I want to find out something intelligent about it. That could be at an individual patient level, at a health system level. It could be a number of different use cases. And then ultimately authoring as well, for being able to create your own code systems and value sets and concept maps as well. So another really core concept in the FHIR Terminology Service is binding. Hopefully you've heard this term and you understand what this means, but just to cover it, it really is a formal declaration of the values that are applicable for a particular element. And you would have seen in implementation guides and profiles being defined that you're binding and defining in this context of this particular exchange, these are the allowable values for this particular field, and really is foundational to being able to get information exchange that's consistent and has integrity and is understood on each side of the exchange. So that's managed by a reference to a value set, but it also has these binding strengths, which you would have seen in the specifications, to say that it's a required binding, which means that the value for this particular field has to come from this value set, otherwise it's not conformant. Extensible, which sometimes does get a bit misunderstood, but that's really saying that if you're trying to exchange a particular meaning that exists in the value set that's been bound to that element, then you must use that code that's been specified for that meaning. But if you've got an additional meaning that doesn't exist in that value set that you're trying to exchange, then you can use an additional code beyond that set. Preferred's really, as it sounds, we'd really like you to use the values from this value set, which is great for interoperability, but you can kind of use whatever you want. And then there's example bindings, because obviously, particularly in the base spec, it's intended to be profiled in implementation guides. And so some of these elements really only have an example to give you the idea of what to do with that field, and then you just have to go and create a special binding for that for the actual implementation you've got. So where do you find codes in FHIR? In a number of different types of data types. So there's the code type, which is simply just a code. The actual code system is defined in the base resource or in the specification. You have coding elements, which allow you to specify a code and a code system, and optionally things like a version and a display and user selected. You have a thing called a codable concept, which is a way of having between 0 and many coding, which is the line above, plus some text. So worst case, it might just be some text and you don't actually have a coding at all for that particular element, sort of a breakout. But you might have text plus a number of codings, and I've got some examples to come. And then you do have the quantity data type as well, which has both a system and a code element for the unit of measure that's for the quantity. They also, codes also appear in searching. So there's the token type that's used in searching. For that, you can specify a system and a code, just a code, which means kind of any system. You can specify a code, this particular special case in here, which is really a code with no system. And there's various different modifications of using this syntax. And then the modifiers down here allow you to modify your meaning of that. So you can sort of say where the code is below a particular code that you're specifying. So you're saying you might put in let's say diabetes, the code for diabetes, and you're saying below diabetes, it's all subtypes of diabetes. And that uses hierarchical relationships in the code system. So taking a resource to have a look at where the codings are. So this one here is just a code. That's the coding type that we saw before. It's the in progress is the code system is specified in the spec for that particular element, so it's already fixed. There's no need to say it. This is a coding, so it's got a system, and then it's got a code, and so it's a V3 ACT code. This thing here is a codable concept. So what we're seeing here is that the text, which will be the text that the user saw, is suspected COVID-19. And this coding has two codings. One is an ICD-10 code, and then the other one is a SNOMED code. The interesting thing about the SNOMED code is that you can see this user selected, which is telling you that this was the code that was actually selected by the user, and this other ICD-10 code is another translation being provided along in that codable concept. So talking about the FHIR resources, I'll go through the three main key resources, and we can have a look at the other bits that sit around it. So it obviously all starts with a code system. A code system is just a set of codes with a set of meanings. It has a series of metadata attributes like URL, version, name, the sorts of things you'd expect to see on a resource. It also defines the properties for the code system, so that the properties that the concepts on the code system can have, as well as the filters that you can use, which are usually related to those properties, to allow you to filter the code system, usually in value set definitions. And then concepts themselves will have things like codes, displays, definitions, etc. Then you have a value set. So a value set is a thing that selects a set of codes to be used in a particular context. They might be the set of codes that I've defined as the binding for a particular element for a data exchange. They might just be a set of codes that I'm using as a reporting category, but they're a way of identifying a set of codes for a particular purpose. And they select from one or more code systems, so value sets can actually span code systems. And then the rest of the picture is you have ConceptMaps. So ConceptMap maps from a source to a target value set. It's directional, so it is mapping from a source to a target unidirectionally. It allows you to have a relationship between the code on the left and the code on the right. So that might be that they're equivalent to each other. It might mean that one has a narrower meaning than the other or broader meaning than the other. Or it might just be that they're related in some way that's meaningful in the purpose of this concept map. The important thing is that the concept map is actually mapping from a value set to a value set. So the concept map itself is quite context laden at this point. So it's not mapping from a code in a code system to just straight to another code in another code system. It's mapping from the code included in a value set in the context of that value set, which is the meaning of that value set and why it's in there, to a code in another value set which has all of the meaning of that other value set layered over the top of it as well. And then the concept map joins those together, and usually they become quite context specific and quite use specific concept maps. So the key operations, so these are the three resources we just looked at. So code system has the lookup operation, which is about telling you about a code. So you can look up a code in a code system, and you'll find out things like its definition, its status, designations, other properties, that sort of thing. You can use the validate code operation, which will tell you if a code is valid in that code system. Validate code also exists on value set, which is telling you whether it's in the value set that you're talking to, as opposed to it doesn't exist in the code system. Subsumes from the code system will tell you about the kind of hierarchical relationship between codes. So you can find out whether two codes are equivalent to each other, or one subsumes the other, or whether they're just not related to each other at all hierarchically. Value set, the main operation is expand. So expand, you can think of value set as like a definition of a set, and expanding the value set is saying, okay, run that query and find out what are all of the things that match the definition of that value set, what are the collection of codes that match that. And there are some filtering operations that go over the top of that, which we'll get to in a bit. And then there's concept map, which has a translate operation. So it's really, given this code, find out for me what this code translates to in that concept map. What are the other codes on the other side of the map? You can actually use translate in reverse. So even though I did say before maps are unidirectional, there is a reverse flag on translate. It sort of doesn't really mean maybe what you might think it does. It's not kind of a reverse map. It's actually saying like what are the codes that map to this code as opposed to what does this map to in reverse. But it's a strange concept to get your head around. And then this is the diagram out of the specification. So we talked about CodeSystem, ValueSet, and ConceptMap, and there's some good examples in here. So we can look at this ValueSet being SNOMED CT fracture codes. We might have a ConceptMap up here, which is mapping from this SNOMED code of fracture of shaft of ulna to this ICD code, which is unspecified fracture of shaft of unspecified ulna, initial encounter for closed fracture. So these things clearly don't mean the same thing as each other, but then maybe in the context of that concept map, they're actually equivalent for the purposes of that map. The bits that's sitting around the side out here we haven't talked about. Naming system is about how you identify the code systems. And then the elements we did talk about before, like code, coding, and codable concept, which reference codes out of code systems. And they also conform to particular element definitions, and the element definitions are where the bindings come in that point to these value sets. So one thing worth knowing about are the well-known terminologies. So most code systems can be represented as code system resources in FHIR. There's a series of kind of big, well-known terminologies that kind of can't. So things like SNOMED CT, LOINC, ICD, where the feature set and the complexity, particularly in SNOMED, can't actually be represented in a code system resource. The code system's not expressive enough, and that's a deliberate choice in code system because it's kind of the the 80-20 rule in FHIR. You don't want to make code system complex enough to deal with the most complex thing, and therefore really hard for all of the simple things. But something that comes along with these code systems is that while they don't have a code system, a FHIR code system rendering, there's built into the specification details of how a terminology server that's conforming to the terminology services specification should represent these code systems out through the terminology resources and their operations. And they will come up with standardized code systems which include all of the metadata but none of the content of these code systems because they're too big and can't be represented that way. But also defines all the things like the filters and properties that exist for them, and things like implicit value sets and implicit concept maps, which are a pretty powerful concept. So if we have a look at just SNOMED and LOINC, and I won't go through all of this in great detail, but you can see here at the top, both SNOMED and LOINC define kind of URIs and URI patterns for being able to identify them. SNOMED CT's got an identifier specification which explains how all of these identifiers work. There's a series of properties that are defined for SNOMED and LOINC based on their features, things that exist in them like normal forms and module IDs that exist in SNOMED that don't necessarily exist in other things. It once again defines their filters and how subsumption works, what their hierarchical relationship types mean. Then you get things like implicit value sets. So implicit value sets are the ability to have value sets or a URI scheme defined in the specification, which allows you to build up a URI that identifies a value set that you can use in things like expand operations and validate code operations. But you don't have to create an explicit value set resource and post that to the server for that to exist. All you have to do is tell the terminology server about that version of SNOMED or LOINC, and it knows immediately, implicitly, about all of these URIs and what to do with them if you ask for one of them. So you can do things like there's a URI for all values, all codes in the code system, not so interesting. But there's more interesting ones like this one, which will implicitly define everything that's a subtype of a concept, and that can work for any concept ID in SNOMED. You can get a list of all of the reference sets that exist in SNOMED, where a reference set is kind of like a value set. A reference set in SNOMED is a way of collecting a bunch of SNOMED IDs together for a particular purpose. And you can even do sort of powerful things like ECL, which is SNOMED CT's expression constraint language. You can think of like a query language. And the great thing about this is you can create an expand operation call, send that to the server with one of these special URIs with a piece of ECL on the end, and sort of dynamically ad hoc query the server without having to predefine any value set resources. And it works great with web caches as well, because it's all GET requests and they can get cached. So having a look at some use cases. Let's have a look at data entry first. To do data entry, you'd choose a code system or code systems, ideally standard ones, and you'd choose or define value sets. Again, ideally choose value sets that others are maintaining, because they are effort to maintain. If you had small value sets, you might make a pick list that's just populated out of the values that you get from expand. If you have a really large value set, and there's this example UI that I've got in the slides here, which you're welcome to go and look at. It has a demonstration of how to do this well, just using the FHIR API. It was built for SNOMED International, so that's why it's a SNOMED thing. But it allows you to flip between our terminology server, Onto server, and SNOMED International's, which is Snowstorm, to show you how you can flip between the two, and it's just using FHIR for interoperability. And each one of these little eye icons tells you about how the text box actually works, so it's really just demonstrating how that works. And some of these have got 100,000 concepts behind them in that, and it's all about how well that type of head search works. So to have a look at an example of the expand operation for one of these pick lists, this is administrative gender, so you can send an expand operation to identifying the value set via its URI, which is the URL parameter, which is somewhat confusing. And you'll get back an expansion here, which has got 4 codes, which you could put in a pick list. So a little bit more interesting is using the filter operation. So you can see this is the URL is one of these implicit value sets that I mentioned before. This is a value set for LOINC, meaning all codes in LOINC, essentially. And the filter is urinalysis. That's what the user's typed in, and we've said that we've got a count of 3, so we want three things back. And what this has sent back to us is that there's actually 52 things that match, but it's playing back to us at parameters here to the request, and we've asked for 3, and so it's given us the top 3. And what it's given us is the 3 most relevant things in a ranked order, according to the server's ranking, and that's up to the server to do the relevance ranking for you. Expand using context is a really cool concept. So this is the same sort of idea as the previous 2, except instead of having to know the particular value set that you want to use, the client application just says, look, the context for this is I'm populating the medication.status code. Terminology server, you've got the structure definitions, you know what the terminology binding is, you go figure it out and just give me the answer. And so what it's done here is come back and actually resolved and said, well, this is medication status 4.0.0 is the code system that it's used to do that. That should be a value set URI. Maybe is actually. And then it's given us the expansion of the particular values that it's used for that. So that's a really powerful concept, because then the clients don't need to understand what all those bindings are. They can be delegated out to the server. And this works for validate code as well, and it works with profiles too. So you can say, medication status in the context of this particular profile. So another use case, validating data, mentioning validate code. So validate code, you can use a code and optionally a display to validate against a value set or a code system. So it works at code system level as well. You can use an existing value set or an implicit one of those implicit URIs I mentioned before, or you can kind of post a value set on the fly to the operation. You can pass in just a code as a code system version or a coding, or you can even post in just the codable concept, and that's great because you can just grab it out of the resource and stick it in the request. It'll tell you whether the code is a member of that value set, essentially, and if you provided the text, it'll tell you whether that's the right display text for that code as well. So if we have a look at an example, this is a validate code operation against, again, this value set is an implicit value set, meaning all codes in SNOMED, and the system is SNOMED, and the code is a SNOMED code, and that's come back and said to us, yes, that's valid, that's a SNOMED code, and its name is dengue fever. If we take an example with validate code using a display, we can say here that this again expanding against or validating against SNOMED, and this is a particular code, and the display we've got here is hypercholesterolemia. And what we've got has come back here has said that that's actually false, that's invalid. If you read the text there, it'll say that this code is in the value set, but the display hypercholesterolemia that we put in there is actually incorrect, and it's given us what the correct display is. Which brings me on to an interesting topic. How many ways can you spell hypercholesterolemia? So, I've got a pair of onto-server socks for the person who can answer the closest. So, who wants to have a guess? A friend of mine or a colleague of mine actually went and did an analysis on some structured data that she'd had. It was actually free text data though, and she didn't count the difference in spelling between American and British, but she counted up the number of different ways hypercholesterolemia was spelled. So, who wants to have a go? How many? What numbers are you going to throw at me? 10, 35, 22, 15. Anyone else want to have a guess? 18. Okay. The answer is 728. I guess, so who had 35? I'll give you a prize right after the thing. Yeah, it's amazing. If you make people type and spell, they'll get things wrong in creative ways. So controlled vocabularies, even outside of terminologies, are a really powerful thing, right? Exploring a set of concepts, like finding out about a code. So we can use the lookup operation to find out about a code and its properties. We can also use the expand operation to ask for a set of codes and their properties, so we can get back properties in expand, which is particularly good if you're wanting sort of the same set of properties for a whole chunk of codes. And we can use the child and parent properties in lookup to look hierarchically at how concepts relate, or you can use that sort of subsumes operation I talked about before, or closure, which is even more complicated, and I'll talk about that in the next session. There's Shrimp is the thing that I've put there, which is a terminology browser. It's a FHIR-based terminology browser. So all of what it does is all based on just the FHIR requests, these particular requests. And it's a great way if you're interested to figure out cool ways of doing things. You can look into, just open up the network tab and see the requests that it's firing as you browse around, and you can get some interesting tips on some cool usage. So anyway, lookup. Here's the lookup operation for a code WA out of a code system that we've got for an Australian jurisdictions. It's just a dummy code system. And what we get back from this is a parameters resource, which will include things like the display, which is Western Australia. We'll get back a designation, which is West Australia. So that isn't the display term, but it's an acceptable term. And then down the bottom here, we've got a property, which is the parent code is AU state. So Western Australia is a state. We've got states and territories, which are different types of jurisdictions in Australia. This is a subsumes operation. So you can see here code A and code B. In this case, code A is a SNOMED code for body part structure. Code B is hand structure. And what the result of this has come back and said subsumes. So what that means is that that body part structure subsumes hand structure. So hand structure is a type of body part structure, and it's between those two codes, the relationship between those two codes. So translating between code systems, once again, ConceptMaps map between value sets, and it's, context really matters between the two of them. But example uses might be things like, and there's lots of uses for concept maps, but mapping from clinical codes to administrative codes for billing purposes is a classic use case, for reporting as well. And you might find that you might be mapping from SNOMED to ICD for billing and mapping from SNOMED to ICD for reporting, and there'll be two different maps because the billing often skews the way that it's being used. You might map from legacy codes to replacement codes. You might map for a whole series of different reasons. So this is what a translate operation looks like. This is another kind of cool one because this URL is for an implicit concept map in SNOMED, which is a map that says for this inactive concept, what's the replacement active concept for a code that's been inactivated. And there's not many code systems that have that kind of feature. It's really cool that you can interrogate the code system for replacements for inactive things. What you get back is a thing like this. It's sending back a parameters resource, which will have a top-level thing telling you whether there's matches or not, and then you can have a look at the matches. In this case, it's saying that it's equivalent. The original concept out there, I know, was actually bronze diabetes, which got replaced by diabetes mellitus, co-occurrent and due to hemochromatosis. And then it's provided at the bottom here. This is the map that it came from, is what that source URL at the bottom means. And it always does play back to you what source the thing came from. There's another map example I've got later in the next presentation, but I better hurry along. Categorizing coded data. So if you want to categorize coded data for reporting sort of purposes, there's actually a few kind of ways of doing that. You could first use translate to map sort of foreign codes you don't understand, into codes you do understand for the purposes of your analysis, and then do the analysis on the translated codes. You can actually define maps, and I've seen this done where people will define a map from the coded data they have to codes which represent the analytic categories. So they're just mapping directly to the analytic category codes, and their analysis is much simpler on the coded data result that they've got. Or you could use subsumes or the closure table, which is in the next presentation, to look at and chop up your data and analyze your data based on the hierarchical relationships that exist within the code system you've got itself. And then the final way that I've seen is people will use validate code. So you might define value sets which define the groupings that you're looking for, and then you're testing using validate code to find out whether that particular record belongs to that group or not. So just a word on kind of global adoption. I suppose it's worth noting that the FHIR Terminology Services has really become kind of the de facto standard for terminology API, not really just for FHIR. I mean, obviously it works great when you're using the entire FHIR ecosystem, but even outside the FHIR ecosystem, even if you're not using FHIR at all for anything else, it makes a great terminology services API. There's been a growth of national terminology services that are rolling out across the world, which is also really good. It's excellent for sort of the base and core implementation guides that are being created in a number of different nations, including my own. But those terminology services, national terminology services, are awesome for developers and organisations that are trying to implement, because then there's a whole set of maintained and ready to go code system and value set resources that represent all of the code systems and value sets that they need to use in their local area, rather than having to get these XML data or spreadsheets and stuff and then have to turn them into FHIR resources and load them themselves. You can just suck that content straight out of the National Terminology Server. It's also been really good for kind of collaboration and harmonisation, because these nations are kind of finally working together and trying to collaborate on and trying to use the same content. So it makes it much better for cross-border exchange and integration, but even just simpler for vendors who are trying to deploy in multiple regions. It's much, much easier. And ultimately, it's great for data quality, consistency and sharing of data, and interoperability analytics generally. So where to find out more? Obviously, the FHIR specification is a good place to go. So there's the FHIR specification terminology service page. The second link, and hopefully you all got these slides anyway, but the second link is to a page that we've got on our site that really is just a list of links to other things where there's educational resources like DevDays talks from us and other people, and all sorts of other useful sort of learning materials. And one of the things I'd definitely plug trying is OntoServer has a Postman collection that has just a stack of examples that you can use to go and play with the terminology service and all of these various features I've talked about, and many, many more. It by default, it'll just run against our sandbox server, which is public and open and free for people to just go and play with. And so it's a great way to go and find a request that does kind of what you want to do, and then tweak it to make it do what it is that you want to do, and then take it off and go and do what you want with it. So yeah. So wrapping up, what we've covered is we've talked about the FHIR Terminology Service, and hopefully you've got a better understanding of what it is and what its value and role is. We talked through the key resources and operations, so CodeSystem, ValueSet, ConceptMap, lookup, expand, validate code, and translate are the main things to take away. Been through a few practical use cases on where you would use it and how you would use it. Hopefully people understand the benefit of this sort of service and the way that it just makes it easier to pick up, immediately start using, sometimes quite powerful, difficult to implement services without really having to do anything other than know how to call a simple API. And that's really the objective of the FHIR Terminology Service. And then, yeah, hopefully you've got an understanding of where there's some of those opportunities to use the growing number of national terminology services that are coming out. And hopefully there's a few resources to look further if you want to. If you want to get in touch with me, there's some details there, or OntoServer support is me and my colleagues. Obviously, OntoServer's a product itself, but we're more than happy to get emails in there just asking questions about the terminology service in general. I'll be around for the next couple of days, and I'll have another session directly after this, which goes into some more of the gory detail of some of the more complex topics. But yeah, thanks for listening.
Are there any questions?
There was another operation that it was mentioned here on the slides, but if you talked about it, I missed it. The closure.
Yes.
This is something I couldn't understand by now, so I was hoping it wouldn't take too long if you can, in a few words, explain what's that operation about. Yeah,
sure. So in the next presentation, which I'm going to do directly after this, there's a whole section on it which explains kind of exactly what it is, but it's about essentially creating a transitive closure table and maintaining that transitive closure table, which gives you a set of hierarchical relationships you can easily kind of get into tabular form and join to in SQL queries, essentially, or tabular sort of queries. But if you've got time to hang around, it goes through it in detail in the next presentation. It is a commonly misunderstood or not well understood topic.
What would your recommendations be if an organization has some metrics that are specific to its own organization, and if it wants to create values or value sets and its own terminologies?
Sorry, so value sets on its own.
So for example, if there's a metric on seeing how soon can a certain problem be solved, or how soon can a specific condition be treated, and it wants to kind of create a value set or a code and a value set, what would your recommendations be in terms of getting that process started? Because that is such an internal concept for that organization, not out there done by anyone else. How would they go about getting that process started on documenting that and keeping it.
Yeah, so I'm not totally sure I understand, but I'm happy to talk it through with you. But yeah, you can create your own code systems, and if codes don't exist for what you want, you can create value sets as well, which are selecting from existing code systems, including your own code system. And then you can take that kind of extra step, which is in the next presentation, of even adding properties to codes from existing code systems. If you're wanting to kind of associate, like a fictitious example of maybe there's a medicines terminology and you're wanting to annotate them all with prices, which don't exist in their code system, you can add those sort of properties onto code systems as well, which is a more powerful feature. But I might have to chat to you about the specific use case you got in mind. Yeah.
Thank you.
Other questions? Thank you, John. Great presentation. Quick question about if you wanna have your own local codes, how that will set? If you are we using FHIR Terminology Server for that, or you have to? If you can explain a little bit how your local code will be set in this whole architecture.
Yep.
That would be great. Thank you.
Yeah, so we find this a lot so we've worked with a number of nations and others who have set up terminology services, and I guess it depends on what you're working with. So some will choose to, if they've got, for example, existing code system sources, they might be produced out of government departments or something as XML files or spreadsheets or whatever, then if that's an existing process and it's going to be ongoing, usually we've ended up creating simple transformations that will transform from those into the appropriate code system and value set resources. We often open source them so people can steal the ideas and go and do that as well. The other option, and we've also seen this done, is if you're managing that FHIR code system and there is no existing source or not a good one, and it's got to be done manually anyway, there are tools for authoring the resources directly, and so you can use a FHIR Terminology Server as kind of like your repository of where you author things, and then you can use an authoring tool, like we've got Snapper is our kind of FHIR authoring terminology resource authoring tool, and you can maintain the resource there directly.
Any more questions?
Okay.
I can ask you one.
Sure. Yeah, okay.
So at FHIR, we've been developing the validator in the SDK, and we sometimes call an external terminology server to validate a code for us. And what we experience is with different terminology services, they sometimes give different response codes for the same error. For example, like they can't process some kind of code, or they can't process a code system. Is that documented somewhere, what they should return, the HTTP response codes?
The HTTP response codes?
Right.
Yeah, typically you'll get an HTTP response code, but you'll get an operation outcome, which will have much more detail about what's actually happened.
Sure.
If you want to kind of yeah.
So we have to always just your advice will be just ignore the response code and just check the operation outcome.
Yeah, well the response code will give you a blunt idea of what's happened, but not probably the exact idea of what's happened. Maybe the difference between the terminology server doesn't have that code system versus that code doesn't exist.
Sure.
It's
a different response code in our experience, at least.
Yeah.
Do you think it's a good idea to actually standardize those?
Yeah. I think that is.
Maybe we should work on that.
Yeah. And look, we've had a bit of experience with validation as well. So our terminology server supports validation. So it validates like any resource type.
Right.
But it uses the happy validator hooked up to then all of the terminology calls all happen internally. So it'll do full validation of the resource, including those terminology elements. But obviously it's slow. The happy validator is not necessarily quick.
Sure.
So yes. But I think to be able to do that validation, particularly where you end up with, in some places the definitions of value sets containing, SNOMED ECL, you kind of almost need a service that can process that ECL at that point.
Definitely.
There's not many that can do it.
No.
Yeah.
All right. Thanks. I think we are at time. After the break, you will be giving another presentation, right, about more advanced topics?
Yeah, things like closure.
People, thanks.